With this video, we are going to use a wind tunnel to take data, laboratory data, for a series of shapes that are going to be placed inside a wind stream. With that data, we are going to calculate the drag coefficient that's associated with each of these shapes. The wind tunnel itself is commercially available. It's an educational wind tunnel, and it has dimensions of 6 feet long for the entire length of the wind tunnel. It also has a cross-sectional square area of 12 inches by 12 inches, and the test chamber measures 18 inches in length. So before we take data, one of the first things we want to do is to calibrate our instrumentation. Here we're going to calibrate our manometer, which measures the speed of the air in the wind tunnel. First, we ensure that our manometer is level so that the fluid levels here are not skewed by the manometer being not level. Then we use the 0 setting here to adjust this fluid level until it reaches a 0 value, doing our best to approximate that line of 0 with the meniscus of the fluid. For our next step, we will need the dimensions of our sample. In this case, we're going to start with a cubic sample. The cubic sample has a height and width dimension, both of 7.0 centimeters on the cross section that will be facing the airstream. And then its depth dimension along the airstream will also be 7.0 centimeters. We'll now take the sample and place it inside the wind tunnel, where we can bring it down and mount it on the mounting plate, which will help measure the amount of drag experienced by the sample when there is something pushing on it. To operate the wind tunnel, we will first turn the power switch on for the wind tunnel itself, and then we will also turn on a power switch for the control unit for the wind tunnel. We will be able to control the wind tunnel speed using the dial here, which goes from 0 to 10. And while we are controlling that speed, we can pay attention to a couple of outputs. The first output will be up here on the control unit, which will be the output that comes from the measurement of the force being placed upon the sample unit. This output will be measured in grams, which can easily be converted to an actual force, even though grams is a mass value, which can easily be converted. And then we will also be looking to the manometer, which is up on the screen, to see a measurement of the wind speed of the air that is being put through the wind tunnel. So the structure for our experiment is going to be something like this. We are going to adjust the wind speed dial in certain increments, going from the value of 0 all the way up to the top value of 10. As we do that, we are going to want 2 dependent variables that we're going to read. The first is going to be the actual wind speed measured on the manometer. The second is going to be the drag force measured in grams as read by the control unit. We will want to record all 3 values, although actually the wind speed value here on the gauge is not important for our data. Do note that as we do take the data, the first values of the wind speed will actually result in 0 force, as the amount of drag force will be below the threshold that can be read by the control unit. So we will actually skip a number of different values of wind speed until we approach the point where we are going to get close to or get above that 0 drag value.